Day 22, Microarchitectures, Umbraco on Docker Part 2 by Carl Sargunar. Extending our previous demo and running it on physical hardware and using a separate server for something a little extra. In this second part, I'm expanding on the previous sample, and instead of running it on Docker for Desktop on my development machine, I'm running it on a production environment on my Raspberry Pis, with a little something extra special to show it working.
Hi, I'm Carl, and this is part 2 of my video for 24 days in Umbraco. Let's go. So this is me, I'm Carl, same as last time, so yeah. Okay, what did we look at in the last part? We looked at what Docker is and some of the key concepts of what Docker can do, the networking, how Docker can store data in volumes, the configuration required to set up an application with more than one container. We looked at how you set up a container application involving more than one using Docker Compose. We created an Umbraco website, the SQL Server database, the web service as well, and had all that running in Docker and Windows, which is a pretty nice demo. In this one, we're going to do hardware. So what we've got over here is 2 Raspberry Pis. One of them is going to be our server, and the other one is going to be just a display, and we'll see what's happening with that in a bit. The top one is a Pi 4. It's got a Pi Unicorn Hat HD from Pi Moroni, who do lots of excellent Raspberry Pi hardware. So if you want to get into that, fantastic place to go. At the bottom is a Pi 4 8GB, and it's got an SSD running on it just to keep things going quickly. I've also installed Docker and Docker Compose in the bottom one. Just a quick note for those who came to the Umbraco Together conference, this is a slightly pared down demo because home internet is not something that you can rely on, as we found out in the demo on the day itself. But it's still going to be pretty good, don't worry. Okay, one quick note on architecture, which I didn't really cover last time. Unless you're on a new Apple M1 Mac, most of your systems are going to be running one of these two chips, an Intel or an AMD x86 64-bit chip, and that's running the x86 instruction set, which was developed by Intel many years ago. But if you want to host on ARM, and that's not just on Raspberry Pis, because Amazon also run ARM instances on the server. They are much more power efficient. They are, for the same cost, much faster as well than normal x86 processors, and some of the biggest supercomputers in the world are also on ARM. So you need to basically compile any Docker container that you use on the relevant architecture. So you can only if you compile on x86, you can only run on x86. You can't run that same on ARM, and likewise, if you compile on ARM, you can't run on x86. There are ways to do that. There are ways like Docker BuildX, which is a cross architecture building tool, but it's way beyond the scope of what we have time for today. And you can also use something called QEMU. I'm not sure how you pronounce that, but that's a hardware virtualization tool again, which lets you simulate or emulate rather an ARM CPU on your Intel machine. Or you just build up a farm of physical hardware. You have a cupboard full of Raspberry Pis, and you use those as your build environments. All this stuff is, really exciting, and I hope to explore some more of it in the future. Okay, this is the actual demo we're going to be running itself. So we have our application host, which is the first Pi, with a website already installed on it. I've got the database server already installed on it, and I have a RabbitMQ message queue host on there. That's connected to the main network and through there. And these three have an internal Docker network as well, so that's separate to the main network. The containers also have to be aware of each other and communicate with each other. And then on here we've got the LED script and another RabbitMQ client to listen for the messages sent from there. And we have that hat, which we'll see what it's used for later. Okay, let's do a little demo. So what I have here are two terminal windows, both connected to my two Raspberry Pis. The first one is my application window, and if I look at the IP address, I should be able to see that's 192.168.0.144, which is the internal IP address of that one. And this one doesn't matter so much because we're not actually going to directly connect to it, but that is 145. Okay, so if I do a Docker, I'll see that I've already currently got a RabbitMQ container running, and I've got an Azure SQL Edge container running. I just got these set up beforehand because I didn't want to go through the painful process of setting that up, but if there's interest, I'm quite happy to go through and show instructions on how I created and set all these up. All the instructions for all of this is available on this wiki anyway. And there's a wiki which I'll publish as part of this talk. So on here, what we're going to do is I'm going to compile this Umbraco project, which is a standard Umbraco 9 project. It's effectively just using where is it down here? Here we go. So it's a standard Umbraco using the unintended installation. And it's using the excellent clean starter kit from Paul Seal, so high five to Paul for that. And if I do a .NET build, this is my Windows machine. I'm doing this, and not on the Raspberry Pi. It's all fine. So I've pushed all this code up to my repository now. I'm gonna switch on to my Pi, and I'm going to do a git pull. This might take a second. Okay, and now I'm going to do a .NET build. And whilst that's building, I'm just going to copy the script I need to actually create my container. So this script over here, this little command will effectively will compile my Docker image for this Umbraco site and put it into my local Docker repository. So I'm not going to push it to a central repository. There's no point in doing that. I'm doing it entirely locally, but I could also push it to a central repository if I wanted to by doing this, which would send it up to Docker Hub, for example. But because I'm working just locally, I'm going to build a container, and it's going to be called Umbraco Docker. And the context, that last dot, is actually really important because that tells you which folder to work in. So that's built okay. So let's now build our container image. This takes a second, so I may well fast forward it. It's a Raspberry Pi this is compiling on, so it's not the fastest in the world. It just does what it does. Great, now we're done. So if I do a Docker image ls, I'll see, here we go. Interesting, I've given it, not sure why the date's there wrong, but that's fine. We're gonna press ahead. So I'm now going to run this Docker image. So this Docker run will create an instance of the Docker image, and it'll be called Umbraco Docker. And this network is important because that's the same network that the other two containers are on. And I'm telling it that it always should restart itself if it crashes, if it's stopped for any reason. And I'm glad I went through this because that's actually this one that I want. I need to pass in the environmental variable production so that it knows which connection string to use. The D is telling you to run it in a detached mode, which means that if the once the script finishes, it doesn't lock the script in place, so I can run additional commands afterwards. I'm exposing port 80 internally, but it'll be 5080 externally, and that's the name of the image which I compiled. So let's run that. Once that's now running, I can do a docker ps, which will tell me that I have, there we go, my docker latest has been created 6 seconds ago and it's been up for 4 seconds. So now we have our website. And if I hit refresh, this was just the previous cached version, so it'll have to reinitialize the application and everything else. Whilst it's doing that, you can also see inside RabbitMQ, this is the RabbitMQ kind of management console. So this is monitoring the queues that are internally there for the application, and you'll see why this is useful in just a moment. Just like you have the front end, you've also got the same back end inside of Umbraco. So I can, oops, logged out. I'll be able to log back in again, and yeah, it's this normal Umbraco installation. So the thing that I've added to this particular project, and I'm just going to nip back to code for a second, is I've added a specific controller which is effectively listening for just a get in this case, just because I was being lazy, but it's going to get that message and send it on our queue to whoever's listening on the other end of the queue, and it's going to say, hey, whatever name you type into the form, happy 24 days of Umbraco. It'll send that and then redirect you to a thank you page. So I've created a page for that. So this is the normal starter kit. The images are still caching, so it takes a while for the images to actually appear, but they will live. Oh, there we go, there's one. They will slowly appear as I go through. But if I go to say hello, this is the page. So if I type in my name over here, now before I press enter, I'm going to nip over to my terminal window and start my Python script, which is listening to the H5YR, and I'm going to also do that. So that's now listening for here. So I'm going to nip back to this. You can see there's no messages in the queue over here. So Carl, I'm going to say go, and that redirects you to the thank you page. If I nip into here quickly, oh, there we go. There's our message. Just arrived. Just one message. I'll do another one quickly while we're waiting. Oops. Can't type. There you go. Now, whilst that's happening, hopefully on the second camera recording, you'll be seeing there's a second message come in. And on the second recording, you'll see the actual message coming through on the unicorn hat on the Raspberry Pi. So, what actually happened in the demo? This is a little representation of what happened today. So we had our form, which is basically just capturing your username. Then we have our three Docker containers, one with a SQL server, one with the Umbraco web server, and one with RabbitMQ. As soon as the form was submitted, it went to the server. That server received it on an API controller, created a RabbitMQ message and posted it to RabbitMQ. That RabbitMQ sent it onto the queue for any server listening. My Raspberry Pi was listening for the messages, so that basically picked up the message off the queue. This is the second Raspberry Pi. That converted it into, with a bit of Python, to send the message to the hat, and the hat is this little smiley thing over there. And that's the demo, and that's, you know, a little proof of concept of some of the cool things you can do with Docker, with Umbraco, with Raspberry Pis. You know, they're all fantastic devices, and I thoroughly enjoy playing with him, as if you can't tell. Just on my previous attempt at this, I had hoped to host this online so that people can have a go, but I just failed miserably at getting the internet connected, so I'm going to have to hold my hand up and say I'll try it another time when I've got better internet. Also had lots of problems with micro SD cards. It's worth investing in an SSD. Raspberry Pi, the 64 bits, still a bit buggy, but generally there's a specific link in the repo to a version which I used, which is the most stable version, so I'll put some details on that. The repository is online here, and I'll tweet this out again, so yeah, go have a look, go have a play. This is the start of my journey with Docker. I've only been doing this a little while, but I'm going to blog all the stuff I've done around here, and then kind of going into next year, I really want to play with the things you can do with Umbraco headless, play with some GraphQL, see what I can do with that. Also look at hooking up GitHub Actions with Docker, because you can get your containers building automatically, CI/CDs, test runners, manage schedule backups for databases if I want to keep hosting my database on there, maybe not. Do some performance testing, looking at cloud instances, looking at Kubernetes. There's a huge amount of stuff we can do. And I look forward to creating that content next year. So yeah, if you want to see any of that stuff, give me a follow. Thank you very much. I hope everyone has a wonderful holiday. Catch you guys soon. All the best. Stay safe. Bye.
All the code for this demo is available at GitHub, and as before, I would really welcome any feedback. Any problems running this code, please reach out to me on Twitter. You're all awesome. Please stay awesome, stay safe, and see you hopefully soon. Thank you.